Uh,
Hi, Sachin.
Hey.
oh,
We collided, Sachin.
pull request wise.
Yeah,
Can you add me, Pascal? If you're on it?
I can. Do you want to be host today?
Yes. I think Carmen also has one open. Just I'm reorganizing my room. I'm not fully set up yet.
Hello. Morning.
Hello.
Oh,
Hello.
Hello. Martin, your name is too long. Doesn't fit in. Doesn't fit
yeah,
in.
it's always usually.
Doesn't fit in what?
It doesn't fit in the table on GitHub.
Oh, yeah.
But I actually always fix that, but I have to
I'm
do
fixing
it
it.
again.
I just removed the last 4 characters of your name. Okay. People will know. There's only
Yep.
one. There's only one Martin in.
We should just come up with some kind of really cool nickname, like the Wolster, or I don't know. I'm not good at this.
Federator.
Let's not use the nicknames from the Dosh with the big something, right?
Oh, I think I missed that, but I can
It
imagine
was
what.
either like some of the dudes working with Elon Musk that he was going by handle big balls.
Oh, I think I did see that. Yeah.
Big
That
balls.
was online
Really?
handle. It's like really like very, very mature, yes.
Yes.
Well, it's
I
only.
don't know. Maybe he needs to compensate. So let's figure out. You have done that. 1 second. May. There's no merge. I'm refreshing.
Yeah, it seems it's an all Apollo crew right now.
Yes. Is it difficult, Pascal?
Well, I don't know what you're talking about. On my screen, it's already merged.
Ah. Okay. All done. All done.
Was there? It always was there. I don't know what you're talking.
Yeah.
I've added us last week.
Okay, let's get away from the news.
Yeah.
Is Carmen in there?
Oh, and Michael is from Chili Creme.
Oh no, did I really?
Yeah.
Oh no.
Oh, yeah, there's also this one here. Yeah, okay. Let me fix that, Pascal, quickly. And then we can start. So let's take this guy. Yeah, hand merge. Man. Okay.
Well, I wouldn't start there, but yeah, I mean, you will see. You will soon see.
Yes, I saw. It's it doesn't matter. They would anyway on the render thing realign it, but we need order. Okay.
I have a conflict again because Steven's merged.
Hello.
Quick. Yeah.
Sorry, guys. First 5 minutes just merging, but that is
Okay.
okay. Agendas 25, and then we can start. Awesome. Okay. Hi, everyone. Let me remind you that by participating in this weekly meeting, we all agree to the GraphQL spec membership agreement, the participation guidelines, the GraphQL code of conduct, and the contribution guide. If you need refreshers, there are links on the agenda. And with that, let's start with a quick round of introduction. I'm Michael, and I'm the host today.
I'm Shane from Apollo.
Martin from Apollo.
Derek from Polo.
Pascal from Chili Cream.
Sachin from Apollo.
Kevin from the Guild.
I'm Steven.
And there is Steven. And he doesn't exist yet. We're going to figure that out. And with that, we can get started. I think Pascal has done a bit on the planning algorithm. Are there any other topics you want to discuss? If so, we can put that on the agenda. Doesn't seem so.
Yeah, I generously put 15 minutes.
We take the
We
usual
will,
15 minutes.
yeah, we will be done early today. No. It
Well,
will
take it away, Pascal.
Well, I would, but I cannot.
No, you can't.
Now I can. Okay, so I put what we were talking about last time a bit in text, just to walk you through. Plan options essentially starts by initializing the options, including all possible source schemas, because we always start with plan options from a root type, either a mutation, subscription, or query type. Then we split the path. I mean, we can elaborate here how the split happens, but let me just make it quick and dirty. We split the path into a sequence of tuple where we have type and field in the provided path as a list, and then we iterate through it for each path element in path elements. We initialize a new set of options, which is empty, and then we set current type and current fields to the respective elements in path elements. So initially this would be something like query me, right? So this the tuple would be query and me, and that's what we assign to current type and current field. Now for all source schemas in options, that's wrong. For each source schema in all available source schemas, actually, I believe. Or let's just keep it that I thought it through. Let's keep it like this. For each source schema for each current schema in options, we we check if the schema let me think quickly. No, that's the right nesting. For each source schema in options, we have to go through each potential schema, which is essentially any of the available schemas. If the candidate schema does not define the current type and the current field, we continue to the next candidate. If the candidate schema equals the current schema, then we will set resolved schema to the candidate schema. And else we have to find a lookup from the candidate schema, from the current schema to the candidate schema, and set the resolved schema, if we find a lookup, to the target schema. And then we continue. If we're not on the current schema and we don't find a possible lookup, we then just continue to the next candidate. Now, once we have a field and a schema, we can say that, is there any requirement on this field? If yes, try to resolve this requirement. If we cannot resolve the requirement, continue to the next candidate schema. Otherwise, add the resolved schema to the next options, and then we just continue. Like if we don't find anything, then we'll return. Essentially, this is what we discussed last time. It's really rough at the moment, and I've renamed many things, so probably there's still mistakes in it. But the idea is we iterate through the whole path, and then we check for each option, for each schema, if we can resolve the current type. Does that make sense?
It doesn't necessarily make sense for me from the root, but because they're like the list of potential schema, like the list of source schemas, like you're not actually starting from one of those source schemas. You're just going directly into one of the candidate schemas. So maybe there
Well,
should be.
Are you? Like if you have let's say you have two schemas, schema A and schema B, and both define query.me,
Yeah.
then the options of the path me is A and B, right?
It is, but that's not what I mean. That's what you're discovering. That's what you're computing. Like like line 29
Right.
starts from like all available source schemas, and I don't think that serves any purpose.
Line 29, this one?
No, it was line 29 when you had the. I mean, I just mean the first line of that one.
Well, the thing is that we are doing this, we have to always look, when we visit the path, we always have a set of options we have to start from, right? Like in the beginning, in the first iteration, everything would be possible. But we always have a set of options that are where we are currently
Because
potentially.
the outer algorithm, that's what Pascal means. We have the outer traversal algorithm, right? And that
Mhm.
calls plan options. So the outer algorithm passes in, no, it passes in the path.
The path, not the
Yeah.
options. No.
Yeah,
No,
exactly.
the options are always like that.
We are computing the options
Yeah.
from the path.
Yes. But in the beginning, everything would be an option, right? That's the reason why I initialized it with all source schemas, because
Yeah, but I think that where I get confused is the nested loop here. Like why there's like I can see how that's useful like once you're down into the path, but for the first
so let's rename this a bit smarter. So for each option in options, because we have to do the planning for each option, right? When we are somewhere in a path.
when you're somewhere in the path, you do, but I think what's confusing for me is the starting point. But maybe that's fine. Maybe just a consequence of like making the algorithm work once you're down.
You mean just initializing that you actually, well, you would still have to loop over all source
Well,
schemas which define the root field, right?
yeah, but that's what you do with the candidate schema, right?
Yes, that's actually in.
Wait, I think it's changed now. Like there was a nested loop there, right?
Yeah, you have this. We do for each option
Yeah.
plan for each schema.
Yeah, what I'm saying is the for each candidate schema in all source schemas is basically the same thing as for each option in options when you start from the root. So you have like a nested loop, but so you're basically going over every candidate schema
Yeah, I
twice,
see.
or as many times as there are schemas. So it's a product.
Yeah, true. Let me think. I wrote this last night. Why did I add the nested loops? Because let's forget about the first iteration when we go through.
Yeah.
So let's.
No, but I get it for the other ones because you're jumping from a source schema. You're at a source schema and you're trying to figure out like which candidate schemas you can jump to. That makes sense. I just like it's just that you're not actually what you're basically doing here is saying I can be in any of the available source schemas, but I'm still going to check whether I can go to any of the like for each source schema, I'm going to check for all the other source schemas whether I can actually go to it.
E-
But that's really like as a first step, that doesn't really make sense. You're doing a lot of unnecessary work there.
yeah, but later in the traversal, this is correct, right? Because
I think so. Yeah, yeah.
actually, even if I'm on schema A, I have to check if I'm on schema A, I check if any other schema can be reached from this point, and then I just add it to the set.
Yeah. As long as it defines the type and field that you're looking for.
Yes, and I have to do this from each option. Like it could be that let's just give you an example. Let's say we have
Yeah.
A, B, schema A, B, and C. All define the user type, all define ID. That means that what I actually do is when I select query.me and I select the profile, I have three options. I could be in A, I could be in B, I could be in C.
Yeah.
And from here, I also can resolve ABC from schema A over the lookup resolver. I can resolve ABC from schema B and so on. So it's actually an explosion in possibilities. And because it's a set, it's then again reduced back to ABC. So
Yeah. I think that makes sense. We just have to figure out how to describe the initial step and maybe options is actually empty at that point. Like you're computing the initial options by looking at the candidate schemas that define current type dot current field. So query.me, for instance. Like you're only looking for the candidate schemas that have query.me, and that's your initial set of options.
Yeah, because we don't need to check everything because this is already past composition. We know we have a valid compose schema, so we're starting with the compose schemas of and pass is what we're iterating through, and we just need to go check. We found some path on the super graph, and now we need to see what is the possible subgraphs that we can iterate to find this path. But we know it's all valid in terms of like there's no duplicate fields here because of that composition check should be. This is the right because we don't need to like do any of the other stuff, any other checks of composition. This is just the pure checking the paths and iterations of possibilities.
yeah, then we need to word description the sequence.
Yeah, I wonder if you can if we can avoid sort of special casing the initial step and just make it work with an empty set of options. Like if we initialize options to be an empty set and then make sure that the main loop.
Then we wouldn't go any further. As soon as we reach the point where options is empty, the traversal is stopped because then we don't have any possibilities anymore.
Yeah,
It's
but then
starting.
if it's as you pick up a new loop, like I don't know if it needs to be a for loop. There should probably be a while loop, right? And you're iterating through the set. And as if you find, as Martin is saying, like on line 32, right? We're saying through all the path elements. But this is something that should be an empty set as well, right? Like we start at there's no path elements, and then you start by adding the roots
So
to the possible
the path elements, actually are, we know the fully computed path, right? We know we have this as the path. So
Yeah.
we know what the first step, the path elements actually breaks this down into a set or a list. Actually, it's a list of tuples where you have, it's actually query me.
me user profile age. Yeah, okay.
Then
Yeah.
you have profile age.
And user User
User
profile.
profile. Yeah.
That's before that one.
Yeah. Yeah. User profile. There we go.
Right. Okay. Yeah. Path elements are not. Got it. Yeah.
And that's also why I wrote it as a for each loop, because it's kind of not a queue and kind of not a while loop. It's actually just we go through all of the elements, we go through all of, and then we nestedly go through all options and all types. It's not something where we really need a queue at this point.
Yeah.
Yes. You're right.
Yeah. And I think this would work as it's stated. I just like it just there is a necessary outer loop there. Like you're going through all the candidate schemas for like in all the source schemas um, um, for every source schema, even though you don't actually have a starting point yet.
Yeah. In line 38, 39, you're saying, Martin, is that you could collapse this into find all other source schemas that also define the tuple.
Yeah, for the
Yes.
initial one, yeah, because you're not actually making a jump. And
Yeah,
well,
but
and
for-
actually, this is actually more generic. It's not just something that occurs at the first path element, because you could jump to the query root from other places, right?
Mhm.
And you don't actually care what the source schema is in that case. Or am I overcomplicating this?
Well, the query root again is just in you never jump to the query root. You jump to a field in the query root, right?
Oh yeah, you do, but just as you jump to a field in any like we're always looking at tuples. But what I'm saying is it's not just a first path element. You could actually have a schema where like the query root field is returned somewhere further down. That's a bit of an anomaly. So maybe we don't really care.
Yeah, so I was thinking about switching the two, but these two loops are actually important the way they are, right? Because for each option, all of the source schemas could be follow-up options. Like even
Yeah,
if I'm in schema A and I don't define user.profile, my current option is A. And then I have to check if any other field, any other subgraph, source schema, whatever, is reachable from my current position,
yeah.
schema A, and therefore for each available schema.
No, I mean, and that makes sense to me. Like once you have like a set of options, um, and maybe in order to like generalize the algorithm, we don't care about the extra work we're doing for the first element. It just seems a bit confusing maybe for people as well. Like because we're starting with like all available source schemas, and then for every available source schema, we're again going over all the source schemas, even though we're not actually making a jump from one schema to another. Like we're just going directly into one of those candidate schemas.
Yeah, I see your problem. It's actually the first step is slightly different.
Yeah. And maybe there are other steps that are similar to that, where you're not actually making a you don't actually care what your source schema is. Like you can just always go into like a query root, for instance, somewhere.
That's true, but there again, it wouldn't be a problem, right? Because you wouldn't go directly into the query root. You will always go to a query root field, which is then essentially already filtered, current type, current field. So you'd only get, if you go into a query root field, like let's say you have query me profile or whatever, it would probably be like mutation create user, and then you have the query here. And
Yeah.
let's say me, right? That's a pattern that we see people use, that they return in the payload of a mutation the query root so that they can immediately fetch data in one go that they need.
Yeah.
In the client. So if you have this, actually, you have this tuple, right? So you have mutation create user, and then you have the
User.query.
payload query, and then you have
Yeah.
query me. So this would already filter out all of the schemas which do not define query.me.
Yeah, and I think it's fine here because like there's only one option here, right? Like the create user mutation will only be in one subgraph. So the outer loop isn't a true loop. But when you're starting out, when we've initialized options to all available source schemas, we are doing a lot of duplicate work. And maybe that's not important because we don't really care about efficiency, but it might also be confusing to people. Like why do we have that nested loop in the first?
Yeah, I mean, the consequence of not having it would be that we say path elements, but actually skip the first one, right? And then we would deal with the first one here and initialize the options.
Yeah, or special case it within. Oh no, because it's the inner loop. Yeah, maybe there's another way to like restructure it, but yeah, what do people think?
Well, I think as you mentioned, there are basically two approaches, right? So either we say, yes, this is actually somewhat redundant for initialization step. It is an optimization that folks will generally do because it's redundant work. And optimizations are not necessarily have to be included in the algorithms. That's what we said, right? To make them simple. Or we do say that, well, initialization step is it's a different behavior specifically, and this is what you have to do. And this is the custom step before that, before you hit the regular algorithm. So which one we prefer? I think we were generally saying optimizations may not necessarily be part of the spec because to make them algorithmic simpler, but I'm open to either one of them.
There might be another way to look at this, depending on sort of how we define option. So right now we've sort of this seems to suggest that an option is just a schema, right? But maybe the type option is more general and like a subgraph is one type of option, but we also have a null option or like an initial option or something. And then for each option and options could still work, but it would just be like a single element set, a singleton set.
Yeah, and the current query plan code, I think what happens is we basically have a fake subgraph that starts out everything, or a null subgraph is kind of what happens today.
Well, yeah.
Yeah, that's what happens in the actual code, just for what it's worth. Is we sort of have a fake subgraph we can start with, and then there's this other kind of, basically a variant of a lookup edge where you don't actually need to get any fields to take it. But you can jump into the initial query root operation types of any subgraph.
Yeah.
That's just how they do it. We don't have to do it that way here, but that's just what it is.
I think if we come up with like an interesting Greek letter for the initial option, it'll all look pretty decent, right?
Fee. It's always fee.
Yeah.
I'll make a note here. Now, how do I go
I actually forgot that was how we did in the code. I think I saw that at some point, but yeah. Maybe that's not the worst way to describe it.
It also forces us to sort of deal with the other issue of like, you're always allowed to jump to root operation types later on. Like
But
if
you
something
do-
from a returns query, you can always use that and you don't have to use lookup to get there. You can just jump.
Yeah.
But you do that just as a vehicle because you start at the type, or
No. The idea, like the only thing we need here is we need to ensure that on line 46, there is at least one option, like there is an option
But
for the initial case. Like
but when we
that's
start,
actually that's the only role for option, like initially.
but when we start, right, we start always from a pass. And a pass would be like if we are at the root, it would be basically a root field, right?
Oh yeah,
And
but
that
but that doesn't get computed until the nested loop in there. Like, but basically this code is structured in a way that is looking for traversals, right? It's saying we always start out from a set of possible schemas, and then we're looking for a field in a particular type. We're looking at all the candidate schemas that have that, and we're seeing if we can jump to that graph. The problem is that initially, like we don't actually have a source schema. We're not starting out from anywhere. We're trying to figure out where to start.
Mm.
It just there needs to be we reset it anyway. So there needs to be just something in it.
Yeah.
Because the option, I need to think about this quickly because I've renamed it. So let's see. We have the candidate schema, which is used here. The current schema was the option. So that would be option. Where to use the current schema? We need it in the option as well, in the lookup as well. Because you are on a schema and then you need to navigate to a different schema. So it cannot be.
But that doesn't make sense for lookups, right? Why do you need to know where you're starting out from for a lookup? Like you need to check the requirements, but I think that comes after, right? You first need to filter.
Probably the smartest thing would be to just skip the first element and do the decision what options we have as like we just treat the first elements specially. And then the next question is find option through lookup is a bit the question. Because what do we do with the query type?
So why find option through what is that? Why does that need option as an argument?
And it's actually probably just because you start from a schema and it could be that you don't have a path to the candidate schema.
Sure, but isn't that a two-stage? Like, wouldn't you first filter the candidates? Like why?
Because depending on where you are, on what option you're currently on, you may be able to reach a schema because you have a different set of keys.
Yeah.
And maybe not. And
but that also doesn't account for like intermediate steps that allow you to like get the key. So I think we need something more generic here.
yeah, I mean that's
similar
why
to requirements.
That's why it's elegantly abstracted as a method which isn't defined.
Yeah.
It's more expressive. Like there's two things that there's only one way how you can, if you find, let's say we are on schema A and we find B as a candidate because B defines the field and type that we are looking for, then we can actually find this lookup on B, maybe not. And it's find is the wrong term here, but it could be that we have the key to directly call the lookup, but it could also be that we first have to go to schema C to have the complete key to then go to schema B. So that's this is more complicated than just saying, is there a lookup that fits? It's actually a chain of lookups that we have to resolve, maybe.
Yeah.
I mean, as said, that's definitely not what we're going to put in the spec. It's more about the general idea about it. The second thing, which is a magic method at a magic function at the moment, is resolve requirement, which we also have to talk about what we do there, because that's where the nested plan options probably comes into play. We probably do need nested plan options and find lookup as well.
Yeah.
So that could probably just be a find lookup. It's actually, but it's not you don't find a lookup. You find.
No, you do, because like you need to know two things, right? You need to know that a subgraph defines the field you're looking for on a particular type, and you need to know that it has an entry point for that type.
Yes.
No, wait, it's actually more general. It doesn't necessarily need to be an entry point for that type, right? Does it?
Well, it not for the type you're currently on, because you would already, if you're in a data field, you would have it already as an option. Like options would already contain the field, the data field. This actually is only relevant for entities. If you're in a nested type, which is not an entity, which doesn't have lookups and doesn't have keys,
Yeah.
you have already the options in this set.
Yeah.
Because the step before actually resolved it.
So but it is still two things you need to know. You need to know that a subgraph defines the fields you're looking for, the field you're trying to jump to. That's the next path element. But you also need to know that that subgraph has an entry point, has a lookup for that type.
Well, it's even more complicated than this, right? Because that's why this does quite a few things. First of all, when we have a candidate which defines the field, then yes, the first check is there an entry point to solve this? The next check is, do I have the keys in the current option to resolve it? And then the third step is there any path through any other subgraph to resolve the keys that I need to get to this candidate? Because that's possible. It's not efficient, but it could be that the only path from here to somewhere else is to go to A, B, C, D, and then have everything that I need to go to the actual destination. So it's three things, right? Let's remove what's here. So that's the current schema, the target schema, the current type, and the current field. The first check is if target schema defines lookup, or let's put it the other way around, it's easier, not defines a lookup for current type. That's the easiest thing, that's return. If you don't have a lookup, you will not be able to find it. And the second is a loop again. Could be a queue, but it's more complicated.
I don't think we need current field here, by the way, because we've already filtered down the candidate schemas to the ones that support current field, and we don't need that for the lookup, right?
Yes, that's true. That's true. Oh, that was the wrong one. This one.
Yeah.
Just to make sure I'm trying to understand this, this find option isn't actually going to return an option, though, an option being a source schema. It's going to return a path.
It's going to return true or false. Probably. The more I think about it, probably just, is there a path?
Yeah.
Through a lookup to get there? Because we don't care about, in the actual query planning, we would care about the path because we have to build a query plan. But here we don't really care. It's only a point-to-point connection, and we have to see if there's a way to connect these two these two schemas together through the lookups. So that's,
Yeah.
the name is absolutely horrendous, but that would be.
Yeah, and maybe that actually means we can generalize it, right? So it's not just about lookups. I mean, that's all we've defined here. But for instance, for legacy federation, we have our own considerations. But yeah, it's like, is there a valid transition or something? Or
It's actually, can I get there?
yeah. Has entry point, or like
That's it. That's not enough.
can enter.
Can enter.
You shall not pass.
Yeah.
Yeah. Okay.
Yeah, I like that. Reachable. Yeah, that might make sense.
Sorry, I don't have the chat open. What was the suggestion?
Is reachable.
Is reachable from here or something? No.
Is
Or just it's
from
reachable is
here.
fine.
That's
Yeah.
great. I love that one.
Yeah. Yeah, but maybe is reachable is fine because it has the arguments. I don't think that the term option is going to be confusing
Yeah.
because it's more like we have a source schema and we have a target schema. That's sort
Yeah,
of
that's here. That's a source schema. So, and that's also not the current type, but it's just the type. Yeah. And then we can that's gonna be loop-de-loop. Whatever this will be. But there's more, this will be more advanced here. But let's say that is reachable actually returns something good.
yeah.
Then we would add the resolved schema to the
next options. Is that it?
I think
Oh no, that happens down like at 62. That's
the candidate schema.
where's the yeah. That's to avoid doing that in multiple places, I guess. Yeah.
Yeah. So that essentially finds out if the candidate schema. Probably we don't need the assignment because I initially thought that we actually resolved. That's the reason why it's called resolve schema. When I was writing it, I was thinking that we actually resolved through a lookup the candidate the next schema, but that's not the case because we already do this with this loop, right?
Yeah.
So in that case, that's actually not even necessary. We can just say the resolved schema is the candidate.
Yeah.
And
yeah. And we just like continue.
We don't
if not is reachable, continue.
Yeah,
I would turn it around. Like
yeah, I feel you. If candidate schema not equals and
yeah,
not,
or I think the compound conditions are making it more complicated. I would just have multiple if this continue, if this continue, if this continue, and then you fall through
Yeah,
to
from a readability, it would be
Yeah.
much better.
yeah, I mean, makes sense. We could also, use ternaries. They're also very good for readability.
Yep.
Okay.
Yeah, especially if you have the not and then the compound, it's getting complex to read.
I think I just really suggest we change options to
Source
like
schema.
current source schema or current schemas or
Yeah.
something. Yeah. It's still bothered. I can't like understand the options.
Source schemas. I believe I had it as
For-
options once, as source schemas once, and then I added it to
Yeah, I mean it's a bit because of the name, right? Plan options that steers you to one.
47.
yeah.
Line 47 is the
Uh,
what for each. I think we called it source schema singular in line 68. Our current schema. Yeah.
Oh, apparently we have a new pope that just in.
No,
Oh,
really?
Or
That
there's a fire that produces white smoke. You never know, but
Wow.
This was quick.
yeah.
It's only 3 rounds. Okay. So regardless of the new pope, the last section again is we have to resolve the requirements. And it could be that the field that we resolved in the candidate has a requirement, and then we have to figure out what we do with this requirement. And there, we most likely want to do a recursive call to plan options and see if there is a way to get there. And now the interesting thing is that we probably need to give initial state to plan options in this case, because you resolve the requirement from a specific option, from a specific source schema. Like, let's put it this way. Let's jot down some notes here. We have resolved requirement, which has the schema, the type, and the fields. Now you have to extract, I would just write something, so requirements, right? And then we have to do for each requirement in requirement plan options. Like, doesn't make sense, but that's essentially what we have to do, right? For each requirement on this field, we have to initiate the plan options. But
It needs to be more specific though, because you need to be able to resolve it from the current
exactly,
schema.
that's why we need to pass in the initial state here, because you have to actually resolve it from the current, oh, that's wrong. Do you need the path? You do need the path.
I don't think you need the full path, but you need the set of.
Don't you just need to continue? Like, let's say we would track. So let's say we're here and age has a requirement, and the requirement for age,
So let's say it needs birth date, right?
age requires birth date. Isn't then the only thing that we have to plan in plan option this path?
I don't think so, because we're not looking at all the possible options here. We're starting out like we're in the loop for a specific option, right? So
Yeah.
if for instance, if profile exists in A and B, it matters whether we are currently in A or in B.
It's this, but just because we're not allowed to resolve from the source schema we're on, right? Technically, it doesn't.
I don't think it you can resolve from your own source schema, right? Or I guess that fail composition, but the requirement is not the path query.me.profile.birthdate. The requirement is profile type dot birth date. That's the only requirement, right? Like, we don't know where it is. We don't know the path. That's the whole point.
No, and it matters where we currently are, because we're trying to go, for instance, from subgraph A to subgraph B. to the age field in subgraph B. But the age field in subgraph B needs birth date. And now we need to figure out if from our current position, let's say subgraph A, like the user type, we can actually get there.
But we would resolve requirement always through the gateway and not through a lookup, right? A requirement is always
No.
no, you could actually just use a lookup to resolve a requirement.
Yeah.
Yeah.
The ask here is you need to say, hey, plan options. I'm currently on profile.age.
Yeah, I mean, in this
I
algorithm,
need profile.birthday.
Yeah.
Is there a possible path? I'm on this subgraph. I don't know what other subgraphs are out there. I'm on subgraph A. Tell me, is there some way I can get from subgraph A to any possible way to resolve profile.birthday?
Yeah, you actually want to get all of the schemas which define profile.birth date, and then you would reduce the set. You would remove everything which doesn't have a valid lookup for it. You would remove yourself, and then you would check if you have if this type is reachable again. There you go. That's it.
Yeah. But you can pass in, you need to pass in
The source.
so that I guess this is the initial state too, right? Because like the plan options algorithm should accept where am I starting from? And then so it knows how to exclude that. But then like if you have that option, then the initialized state we're talking about from above is
But do we even need this? I mean, couldn't we just say that we say let schemas be the set? That's not that easy. It's not that easy. The set of all available source schemas. And then we essentially remove all schemas that do not define a lookup for type. And then remove.
It seems this is a sub function that we can reuse. Like this is basically what we're already doing above. Like we're just doing it in the main function, right?
Yeah, we just need to pull it out.
Yeah. But what does all available source schemas mean here?
Well,
What makes it
again, you when you have a requirement that you need to resolve, I need to know. Give me a way to fetch user.birthdate. And I don't care where this comes from. It could come from all of the source schemas which are available.
Yeah.
And that's the reason why we have to start with all possibilities. It's all of the source schemas could have this field on this type. And then we remove the ones which doesn't have a lookup because we cannot get there without a lookup. And then we remove the ones which are ourselves, so only one, because we cannot resolve a requirement from ourselves. And then we are left with schemas which define the field and have a lookup. And then we can essentially say is reachable from current schema, target schema type. If yes, good. If not, no good.
I think we may also need, like maybe we can actually call into is reachable from here, right? Because it doesn't have to be just one jump. Like
Exactly.
Yeah.
That do not define type.
But can't we just say remove all schemas that are not reachable? Like you reuse is reachable?
Yeah, I would do it here. Like if there's any that is reachable, because now you could say, I just write it for each schema. If target schema. And then you can say if is reachable, schema, target schema, type,
Yeah.
return true. It's a question of ordering, of course. We can also do it the other way around. Yeah, it's a bit different. The other way around, it actually makes more sense because this is wrong. We cannot return true because we have more than one requirement to resolve.
Yeah.
So your thing would be to filter first and say,
Well,
like this.
I think so. Yeah.
This would go because we already know. Then only this is left. Like to check if something is reachable, we need to pass in the type. Therefore, we also know that the type exists.
We have 4 minutes left.
So I don't think we necessarily need to return true or false from any of this, and I don't think the ordering matters. We just need to see at the end whether like the set of candidate schemas is empty or not, right?
You mean in resolve requirement?
Yeah.
Well, the problem is it's more than one requirement that you can have. You have to do it for each requirement.
Oh, yeah, but if even one requirement fails, you return false.
Yes, exactly. That's the reason why this doesn't make sense. Like we need to be in the situation where we can say this requirement is not resolvable, return false, otherwise return true in that case, right? So we say true. And then
Yeah, so what I'm saying is in that inner loop, like for each requirement, or for that loop, when you start out with candidate schemas and you remove schemas that are either not reachable or that do not define the field, and I don't think the ordering matters necessarily. But at the end of that, if the set of candidate schemas is empty, you return false.
yes. Yes. So that's actually this.
Yeah. But yeah. What's line 79 doing?
Remove myself.
Oh, yeah. Yeah.
Yeah, we have, I mean, spec language, we never have remove. We only add, like we can, whatever makes more sense here. But yeah, and I will have another iteration on this. But generally, I believe we are on an okayish track to
Yeah, next week we can do
Next week
another one on this.
we take another 15 minutes to.
Yes.
yeah.
But I think it's going well.
Yep. Yeah, I mean it's the once we have plan options in, we can think about how we want to put together the spec, because then we have everything that we need for the first draft. All the sections are technically thought about. They're still missing.
There's major work still yet.
Yeah, but I would say the major work, once we have plan options and we have satisfiability in, the major work is done, then it's just making.
Yes, but it's a lot of polishing, Pascal.
Oh yeah,
Takes a while.
it will. But we are closer than we've been ever before.
Every
All
week
right.
we are. Okay, see you.
See you next week.
Bye bye.